Now we're going to dive a little bit deeper. We talked about transactions. I want to show you some very basic transactions that we can perform with our storage. I also want to take a look at some simple examples of implementing OData and how you can make that work without doing an extraordinary, well, not extraordinary, but a lot of extra work using an SAS.
We're going to take a look at a couple different things with our table data. The first is going to be working with table data using the REST API and a little bit of OData. Nothing too serious, but just to give you a little bit of a flavor of what you can do with that. Now, I'm working off of the data that I had entered in the previous demo. And by the way, we're going to modify this data and in some ways modify it fairly substantially as well as part of this. So we're going to take a look at OData and we're also going to take a look at transactions. Now, this data is in the storage emulator, right? So this is my local storage emulator. And I've connected to that actually through my Server Explorer over here. And I've gone into my storage under development. I've got the table rosters and here it is. So here's the data that was entered. Now, if I wanted to get into that data, normally what you're going to do is you're going to connect up through Azure, through the right endpoint in Azure, and using the right security. And that security is usually going to use a SAS, a shared access signature token. And I've actually generated a token for the development account. Now, the development account is a well-known account, and it's got a specific account name, which is DevStore Account 1, and it's got an account key. Now, this is only for the storage emulator. It's okay that this is well known because you would never put anything that would be important there. And so what I did was I actually used a PowerShell commandlet, new Azure Storage Table SAS token, to generate a SAS token. And then that I added to just the HTTP URL for my storage emulator. So the storage emulator is that part right there, that first part, without the pound sign, because that's just the comment mark for PowerShell. Everything after the question mark is the shared access signature. And we'll take a little bit of more of a look at shared access signatures in a later topic and a later module. But for now, I have those two things. And then in between, I have the actual table, which I'm going against, which is roster. Now, if I take this, everything except the pound sign, and I'm going to do this in Chrome because Chrome will just pop out the actual results here. There was an earlier demonstration. All right, so I'm going to take that URL, and I'm going to put that URL in. And that's just the URL with, again, the URL of the endpoint for my development, my emulator, table storage, and then the actual table, and then the SAS after that. And all of that gives me this. And without worrying too much about it, you can pause this if you want and look. This is an XML result that's showing me the actual data. You know, that's the same data that we were just taking a look at. If I can find it here, there we go. The same data that I was just taking a look at here. So that's just an XML representation. It's actually an Atom representation of that data. Now, there's some things that you can do with this. For example, if I wanted to return an individual, I could specify, you can notice little parentheses there, like roster is a function, because it kind of is. It takes two parameters. One would be the partition key. So, for example, I could say partition key equals sales, and then I could add a row key equal to Bob. So if I just wanted to return Bob's record, by specifying that, I'm just getting the record Bob here, and you can kind of see that's got row key Bob and years at company 3. All right, now I can be a little more creative than that as well, in that I can use a little bit of OData. So I'm just going to do, there's different OData query string pairs here, name value pairs. One of them is filter. So $filter allows me to put in my OData query string attribute, and it's going to be add filter, and I'm going to say years at company, which is one of the properties that one of the columns that I've got for the table, I'm going to say greater than 3, GT3. I put less than instead of GT. GT, there we go. All right, and so if I do that, I'm getting back this information. If you want to pause this, you're going to see that there are actually 2 folks that it returns. Now, I can do some more things as well. For example, I could put in a select. Hopefully this will work. I did not think to try this before. Select equals, and I'm going to say select equals, how about just row key? And then an ampersand. Okay, and so what that does is that's only returning the row key. And if you look, you'll see now it actually does a little more than that because there's a fair bit of information that is returned regardless. For example, it's got the href that I can't really control. But again, all of this is in XML. Normally, you're going to do this so that you can then process the XML. Okay, so that's OData. Now what I'm going to show you something that's pretty cool, which is a little bit of the transactions. So let's pull this up. And I want to come over here to my code. So in the original demo that I had done, I connected to the table, and then I just created some objects within the table. Well, I can operate on those objects as well. I'm going to do 2 things. The first thing I'm going to do is I'm going to retrieve, using a table operation retrieve, an employee record for Bob. So I'm going to retrieve with the partition key of sales and the row key of Bob. And then I'm going to execute that. So I get the table operation, and then I return an actual employee. All right. Now the employee, remember, that's just a variable type that I created. A class, that would be what that would be. There's employee right there. Okay. So I can return that employee, and I can update some information. So I updated Bob's years at company to 24. Now, I also created an additional property here, an additional type, not property, an additional class called extended employee. So I created this extended employee, which takes the type employee and it adds a little bit of things to them. Okay, so if I look at extended employee, you'll notice it is, let's go up here. So extended employee is also a table entity, which is same as employee. So it's got the same kinds of functions there. Okay. And then I added a constructor that takes employee, and it just basically sets the same properties from the employee. And because I'm going to do a merge, this little E tag here was kind of important. I may or may not have found that out the hard way. And they've got some additional properties. It doesn't really matter. But so first name, last name, and location that are part of an extended employee. But basically what I'm doing is I'm transforming a record in the table that was of type employee, and I'm transforming it to be of type extended employee. Now let's take a look at the data in the table. So right now, if we look at Bob, that's going to be the focus here. Bob has a years at company equal to 3. So let's go ahead and run this. And so I run that out, and it gets up to the table execute. I'm going to execute that line, and that should put Bob's years at company up to 24. So I am going to, no, not step over. I want to refresh. That's what I want to do. There we go. Okay, so now we see sales Bob, and Bob's got 24 years in service, which is great. Now I'm going to run through the rest of this. So I'm going to create a new Bob record. Then I'm going to create a merge operation with the new Bob record, which is going to have the partition key, the row key the same, that E tag the same, all right, and then some additional data. And then I'm going to simply execute it. Okay, so I execute that, and I can actually run this out, and there's really nothing else going on there. But this is pretty cool. If I go back to the table and I refresh the table, you may not have expected this particular result, right? So now I've got on this third row, I've got the partition key and the row key are, Bob from sales. It's got a timestamp. It still has that updated year as a company, but now it's got this additional data. And so all of a sudden these rows were added to this table, which if you're a relational database person, you're probably cringing right now because that's not what's supposed to happen. But remember the table representation of this data, I mean, it's table data, but it's really dictionary data, right? I've got this entity for Bob in sales, and that entity has several custom properties. I just happen to add 3 more properties to Bob, but now that kind of shows up in this whole tabular format. Sue and Janice don't have those properties because I didn't add them to their record. Okay, so it can be kind of interesting when you start thinking about the transactions with tabular data, with table. I wouldn't say tabular; it's table data, and how you want to use it. Don't be as cavalier as this, but I did want to show you kind of how that works.
Those 2 components, the transaction component and the OData component, those are building blocks that you can take and really go and do whatever you need at that point. If you understand that and you can extend it a little bit, you've got Azure storage.